Review sheet N. 1A, I must find the general solution. I'm going to make sure that my letters that are the same are on the same side. So if I'm putting the m's on this side, then this m here needs to come over. I'll divide by it instead. The 0.4 is staying on this side, and this dt is moving up. Now they're separated, I can integrate both sides. So 1 over m integrates to m, and 0.4 integrates to 0.4t, and I remember my plus c. So to find m, I need to do e to the power of 0.4t plus c. Remember our indices rules, so if I've got e to the power of 0.4t plus c, that's actually the same as times by e to the power of c. This is just a constant, so rather than have e to the c, which is a constant anyway, I'll change the letter e to the 0.4t, and that's my general solution. For part B, I'm given some conditions. This one here initially, that's telling us that t is equal to 0. The mass m is 6. So we're going to take those two values and substitute it in my general equation. So 6 equals a e, 0.4 times by 0 is 0. So to show that question, so show that you remember e to the power of 0 is 1, and so a equals 6. Now we've found a, we're going to write out our equation again, substituting in that value. In question 2a, again, let's make sure we've got the same letter on the same side. So 1 over n dn. The lambda is a constant, so it's just staying there. We're treating it just like a number. dt. Once I've got those split, I can integrate both sides. 1 over n integrates to ln n, and here I'll have lambda t plus c. So exactly the same as in question 1a then. It tells me e to the power of lambda t plus c. Because I can split that up, lambda t times by e to the power of c. This just being a constant means I can rewrite it, that constant in front, times by e to the lambda t. And that's my general solution. Following the same pattern as in 1b, we've got some conditions. Initially, so t is 0, there were 6,000 spiders. So n equals 6. Because in the question I'm told that spiders in a population is n thousands. So not 6,000, but 6. And I'm now going to substitute that into my answer for part A. I'll have 6 equals a e lambda times 0 is 0. E to the power of 0 is 1. It's to show that, so put lots of detail in. So a equals 6. I can now put that into the general solution, and I'll have n equals 6 e lambda t. In part C, I'm given some more information in order to find the unknown, lambda. So it is observed that after 4 days, so t equals 4, the number of spiders has tripled, now 18,000. So n equals 18. I'm going to put these values then into my answer from part B. So I'll have 18 equals 6 e to the power of 4 lambda I'm going to rearrange this then to find lambda. I'll have 18 divided by 6. So 18 divided by 6 is 3. So I've got 3. What's leads the 4 lambda. So now if I want 4 lambda to get rid of this e, do ln 3 on this side, and then my final step will be to divide that by 4 to find my value of lambda, which is 0.275. Part D, find the number of spiders. So I'm looking for n after 8 days. So when t equals 8. So if I write down my equation again, it was n equals 6 e. So power of lambda, now lambda I found in the last part, so 0.275 times by t times by 8. If I put that in my calculator, I get n is 54. So the number of spiders then is 54,000. Question E, when does a population exceed 100,000? So when is a time. It's asking me for a time. This 100,000 then gives me n equals 100. That's the number of spiders. So if I substitute these values into my equation, I'll have 100 equals 6 e to the power of 0.275, my lambda value times t, and that's what I'm trying to find. So the first thing I'll do then is 100 divided by 6, bringing this 6 over to the other side. I'm going to leave it there as a fraction, but you can make a decimal if you like. I'm going to leave that to the end though. So I'm still heading to get t on its own, so I want to get rid of this e. So ln 100 over 6. So the last stage now is to just get rid of this away from the t. So I'm going to move it to the other side. If I'm moving it to the other side, I'm going to do the opposite thing. The opposite to multiplying by it is dividing by it to find t. Put this in my calculator, get t equals 10.23. So when does a population exceed 100,000? 11 days.